Alright, so now that we have the rasters created for our socioeconomic data, we need to use the road network database to figure out the areas that are within 10 miles of driving distance. And then for walking, we're going to look at maybe a few different layers. So like within quarter of a mile, half a mile, and 1 mile. But let's just start with the driving distance. So to do this, you need a network database. We have a road network database that's from the municipality. They're rather expensive databases and they're very complicated databases. I've already added it to my project here. You might or might not have it. I'm not sure if the Muni will release this data since they are quite expensive to build and to maintain. But if you don't have it, just watch what I'm doing. So you're familiar with how to use these databases because they're extremely powerful. And if you do have it, then you can walk through what we're going to do. So these have information for like ambulances, if you're approaching from the right, if you're approaching an address from the left, you know, what to do, how to get there. You can think of it as Google Maps, you know, on your phone. When you put in, I want to go from UAA to the nearest Fred Meyer, you know, these can tell you what routes to go, how long it'll take to get there. It has speed limits, traffic flow, is it a one-way, two-way street, lots of information in there. And so to use this tool, I'll turn on the streets here, you go up to Analysis, and it's called Network Analysis. Click on Network Analysis, and you'll see Service Area. We're going to use this one to generate drive time polygons. So again, find the areas that are within 10-minute drive. So I clicked on it. Okay, here we go. So you'll notice we have this service area here, and we have a lot of different features over here. You can use these to figure out, say, what is going to happen to traffic. Should we close down a section of the road for construction over the summer? If we have an accident in an intersection, how should we reroute traffic? I mean, again, really powerful databases. So I'm going to move our stores up above the top because our stores are actually going to be our facilities. They're the things that we're trying to figure out a 10-mile drive to. So there are facilities. So click on Service Area, go up to Service Area here, go over to Import Facilities, and we're going to import our stores. Just accept everything else and hit OK. And this is an error message about 2D, 3D. You know, your input locations are 3D, which means they have an elevation to them, but this network data source is 2D. We can just ignore that. It's really not important. But you'll see now that our facilities are aligned with where our dots are for our stores. So it's looking good. Alright, so with the service area still highlighted, we come up here and click again on service area if it's not. We're interested in drive time. We are interested in towards facilities, and really all we care about is a cutoff time of 10 minutes. So I'm just going to put 10. For the date and time, you would use this if you were interested in looking at, well, is it a weekday when traffic is horrible and people are trying to get to work, or is it a weekend when traffic might be better? We really don't care what time of the day it is or day of the week. And we do want to have polygons output, so everything is good. We can just hit run. And you'll notice these little locks mean that the data is being used and we cannot access it right now, so we just have to wait for it to run. Okay, it has run. So we have a polygon over here that says a cutoff of 10. So if I click on and off this polygon, this is where it's a 10-minute drive to get to one of our stores. Okay, one thing you'll notice is that it does slightly go outside of our study area here. If I move our study area to the top. So we do have some dangling out here, and we need to get rid of that. We just want stuff within our study area. So I'm going to turn off the streets. So to do that, we're going to do a clip. So I'm going to go up to Analysis, Tools, and go up to It's this analysis tools. I'm just going to close all these that I have open, and it's extract and go to clip. So we're going to take that polygon layer and we're going to clip it by our study area. So we're only interested in our study area, and we're going to leave it within this geodatabase, and I'm just going to click here and say drive 10 underscore clip, and I just hit enter or click off of it and see drive 10 clip. It's just a temporary file that we're storing in the geodatabase that's with our project. So we'll run. It might take a little bit here. Alright, it has completed. So we have our drive 10 underscore clip. I'm going to turn off the service area. Okay, it's clipped to our boundaries we see. Now let's take a look at this attribute table. So right click and go to attribute. Okay, so I'm going to sort by this to break. All of these should be 10s. Yep, because we only did one time and that was to 10. Alright, so we need to turn this into a raster, and in order to do that successfully we need to have information on the entire area. Right now we just have information where this green polygon is, but we need to combine it with the entire study area so we have a seamless polygon that has information on the areas outside of 10 minutes and the areas inside of 10 minutes. To do this we use something called the union tool, but the union tool is really slow. It takes a long time to run. So before you do a union, you got to make sure that you simplify your data first. Make it as simple of a union as possible. And one way we can do that is we don't need to have every single road, polygon in here. You can see if I click on these, there's many polygons. We just basically want this to be one polygon. So there is a tool to make this into one. It's called dissolve. So dissolve will basically, you take a field in your database and you can dissolve on it to create new polygons. You could think of this as if you were trying to recode your data. Say you did a survey and you had 5 categories. You had strong support, you had very strong support, neutral, disapproval, and strong disapproval. Say you had those 5 categories, and you're like, ugh, 5 is too many. I just want to go to support, neutral, don't support. So you're collapsing it down to those 3. That's, in a sense, what the dissolve tool does. It will collapse it down to what you tell it to be the number of categories. In this case, we'll do a dissolve on break. We only have a value of 10 in there, so we should just be left with one polygon to represent the areas that have a drive time of 10. So we'll go up to Tools, and this is down in Data Management, and it's a generalization, because you're generalizing the data, making it, collapsing some columns, and we can click on Dissolve. Okay, now grab your input feature, which is going to be your drive clip. Alright, your dissolve field is going to be your 2, which is all 10s, and we're going to save this because we want, I'm just thinking, no, let's not save it because we still have to do a union, so we'll just leave it as what it calls it. Drive 10 underscore clip underscore dissolve in your geodatabase, so temporary file, because we still have to unionize this. So then hit run. And again, make sure nothing is selected here in your table. Alright, so now let's look at this new attribute table. Ooh, much simpler, much nicer. It just has one polygon in there to represent drive times of 10. Okay, so I'm going to clear that, and I'm going to clean up my data here, remove this other one. We don't need it, this drive clip. Get it out of there. Okay. Alright, so now we want to do the union. Go up to Tools, And Union is up at the top. It's under Analysis, and it's under Overlay, and you'll see Union. Alright, so put the study area in first. Important to put the study area in first. And then we're going to combine it with our dissolve clip. Alright, so we do want to save this file in a permanent place, so click on the folder and navigate to your products. And I would call this drive time, and I'm going to say 10 underscore minutes. That's what I'm going to call it. Drive time 10 underscore minutes. Okay, so save it in your products. Drive time 10 underscore minutes. Everything else is okay, and then hit run. This might take a while to do, so we'll see. Oh, and it was really fast because we simplified our data. I tried it before simplifying the data, and after 20 minutes it was still running. So really simplify your data before you do any unions. Alright, so let's turn off our other drive clip. Let's turn off our study area and collapse this service area. Okay, so now if we go up to Map and we go to Select, when I select, say, this area, it's highlighting this outer area, and when I select inside, it's only selecting R10. So when we open our attribute table, okay, let's take a look at this. So we have this area, which is our 10-minute drive. We have this area, which is just funky dangling areas that probably it looks like we're outside of our study area, but we're included in our drive polygons. We don't want those. So just right click on here when it says -1 for study area, 1 for drive time. Just click over here and say delete row. We don't want those. Alright, let's click on our other row, and that's our entire outside area. Okay, so since we did some editing, we need to go up to edit and we need to hit save. Alright, so we do need to add a new category that we're going to use to create a raster. And I'm going to clear my selection and go add, and I'm going to call it maybe dist, for distance, dist. And I'm going to make it a double, because remember the other socioeconomic data that we rasterized was doubles, so I want them to all be the same kind of fields. So we're going to say distance, distance, double, and hit save. And so also remember that the bigger numbers represented more difficult issues with food security. So the higher the percent of households that were in poverty indicated bigger food desert areas. So we want the areas that are far out here to be a value of 1. So double click on distance and 1. And then we want the areas that are within 10 to be a 0, because, you know, they're within food sources. So now that we edited it again, go up to, you know, your tool bar up here, edit, and hit save. So now this one is ready to be transformed into a raster. But let's do our walking distances next. Okay, so let's clean up our project here. We don't need this clip dissolve anymore. We can remove. Okay, let's go back to our service area. All right, turn this back on. We've, you know, basically we've saved what we need from this analysis that we ran. You know, we have our drive polygons. We're good to go. So the next way we want to use this is walking distances. So with the service area highlighted, go back up to service area, and instead of drive time, let's say walking distance. And we do want towards facility, but we want to do this at 1/4 mile, 1/2 mile, and 1 mile. Okay, so I'll just click off of that. So see, we have 1/4 mile, 1/2 mile, and 1 mile. So we put those in. Alright, everything else basically remains the same. You know, we have the same facilities that we're going to. So now just hit run, And this will calculate the areas that are within a quarter mile walking, half a mile, and 1 mile. And you know, this isn't going to be as the crow flies. This is as people have to maneuver around blocks and stuff like that. So it's more accurate than just doing buffers. All right, I'm taking a look here. Okay, so it does bleed a little bit outside of our study area here. All right, so you can see here's the ring for a quarter mile. Here's the ring for a half a mile, and then out here these guys are a mile to the nearest grocery store. Alright, so it looks pretty nice. Now basically we go through the exact same processes that we did with the drive time. Alright, you know, as I said, repetition, repetition. So I'm going to turn off this drive time, turn back on our study area so we can see what we're doing. I mean, it may not look like we need to clip, but you know, there are some dangling artifacts there. So the exact same process. We go up to analysis tools, this first analysis tools, extract, and then clip. Our input is going to be this polygons again. This is this polygons right here. Our clip feature is going to be our study area. That's what we're clipping it by. And I'm going to call it, you know, walking, and click off of it, walking clip. So we know this is our walking clip. All right, then I'm going to hit run. All right, so we have our clip. I'm going to turn off the service area. We don't need that on. All right, so the next thing is we want to do that dissolve. So I'm taking a look at here, and we have our 2 breaks. So our 2 breaks are going to be, you know, that 0 to 0.25, so that, our half mile and our mile. So if we go select by attributes, and we go select by attributes, and we go 2 break, and we choose, let's say, the quarter of a mile, well, this should light up all the areas that are right around the circles, you know, right around our stores. And it does. Okay. All right, so we are going to dissolve again on this 2 break field. So close that, make sure you select, clear your selection, go again back to your tools. Now we want to do the dissolve, which was under data management, generalization, and dissolve. Choose your walking clip. Your dissolve field is going to be that 2 break, and again, just leave that temporary file because we're going to have to do the next step of the union, and just hit run. Okay. Close that down, turn off this walking clip. So now we have our dissolved. We'll take a look at the attribute table. Yay! Only 3 of them versus several hundred for the other one. Alright, so now we do our union. Tools. Go back up to the top, analysis tools, overlay, union. Again, put the study area in first, very important. And then put our dissolve in, walking clip dissolve. And we do want to save this, so click on the folder. And I'm going to say walking time miles. So walking time miles, then hit save. Okay, we got all this, and then hit run. Okay. Alright, so turn off the walking. Alright, let's take a look at our attribute table here for our new union. Okay, we have our breaks here. You can look at it. Okay, so I'm going to just select by attribute to take a look at what's going on here. So when our break is equal to 0, it this should be the outside. Yep, so when our break is equal to 0, this is where we're beyond walking distance of a store. Okay? All the other ones were within walking distance of a store. We're either within 0.25, 0.5, or a mile of a store. So I'm going to hit clear. And just like before, we need to add a field that's going to be used to turn this into a raster. So click Add Field. And for this, we could say distance again, D-I-S-T, and make it a double. So D-I-S-T, D-I-S-T, double. And hit Save. Okay, close this down. Alright, so remember again, 1 is the maximum value for far away. So for this one, we're outside of our walking distance. We want this to be a value of 1, the highest value. Okay, so let's just use the values that we have for the break distance to be this distance. So when the break distance is equal to 0.25, let's select that. We want the distance to be 0.25, so use our calculator, field calculator. 0.25. Hit OK. Alright, so when the distance is 5, this is select by attribute, then field calculate. We want it to be 5. And then when the distance is equal to 1. When the distance is equal to 1, let's make that equal to 0.75. Okay. Alright. And hit clear. And now let's just kind of visualize this to see what's going on. So the values are lower the closer it is to the store, and then it goes up, increases. So right click on this and go to symbology. And then click, how about graduated colors? And then click distance. And there you can kind of see. You can see the distances there. Okay? Alright. So I'm going to just turn this back into a unique value here, so it's just all one color. Okay. Alright, so now we need to clean this up a little bit. We can remove these other walking files. So click on one, hold down the shift, click on another one, and we can remove both at the same time. Right click and go to remove. Alright. So we have our walking time. I just want to take a look at this attribute table again. Okay. Alright, and we have our drive time. We need to convert these to a raster. One little tip and trick is that, you know, if this is your same project, and it should be your same project, you can actually view your history and kind of recycle your history to make sure your settings are all the same. So what we could do is we could go to analysis here, and we could go to history, and we have our history up. This is all the geoprocesses we've done. And so what we can do is we can say, oh, we've done this conversion before, a polygon to raster. Remember we had to go in and set the environment and everything. Well, what we can do is we can go back to our history and we can find where we've done this before, and I can double click on it and it pulls it up. So this time, you know, this was when we did the food desert and we created our raster for the percent with no vehicle. This time let's do drive time. So let's, instead of food desert, we want to select our drive time. And the field that we want is distance. Alright. And you notice that you have your path saved right here. So your path to your folder is already there. So one way you could do it is just change the file name here, and we could say this was drive time. And then we have it, and we could just hit run. I mean, if you really want to, you can, you know, browse and re-navigate here, and we could come here and we could do it this way too. I just click on one of these to get the words, and we can do drive time and do it here too. But this is just a cheater shortcut way that makes me save time when I have a lot of things to do. All right, and everything else should be good, so we could hit run. Okay, so I'm going to turn off that, and there we go. We have zeros where people can drive and ones where people can't, so that works successfully. Now we want to do this for our walking, so choose walking, and the field again is going to be distance, and it's not going to be drive time, this is going to be walk time, WALK. Alright, same folder, walk time. You can also click on the folder and go here and be walk time.tif. Alright, and hit run. Okay, so we have a bunch of ones on the outside, so we could go to symbology instead of stretch. Let's use unique values, and yeah, let's do an attribute table. Okay, turn off that one, and you can see, in fact, you know, we do have 0.25, 5, 0.75, and 1, so it works successfully. Alright, yeehaw! Now we have all of our rasters built, and we can do the next step, which was the weighted sums. Okay, so I'm just going to kind of collapse some things here so people can see better. Alright, so here's our 5, 1, 2, 3, 4, 5 rasters that we're going to use weighted sums to figure out, when we combine all of these together, where are the areas in Anchorage that potentially are food deserts. So go up to Tools, and you can, up at the top there's a search box, and we can search for weighted, and there it pops up, sum. We don't want the image analysis tool, we want the spatial analysis tool. So lots of times I like to try to figure out where these are, remember where they are in the toolbox, so I don't always have to sit there and search. So I'm going to click on the Spatial Analyst tool, and okay, this is where this is. It's under the Spatial Analyst tools. It's under a thing called Overlay, and it's called Weighted Sum. So we're going to click on this. Alright, and now this hopefully where all of our hard work and all those steps of data management, getting our data created, will pay off. So we need to check each raster. So walk time, add another. Drive time, add another. Percent no vehicle, add another. Household and poverty, add another. And income. Alright. So yeah, all these selected the field value. I mean, that's perfectly fine. Let's see if we open up this one. Actually, some of them have attribute tables, but this one has an attribute table because we created it, and you'll see you have a value field here. So it'll select your value field for you. Basically, it's selecting, when you look at this, your value, value. So it's selecting, that's the field that's going to be added together. Alright. And the weights, right now we're making each of these parameters the same weight, but say you thought that, you know, income was twice as important as these other values. Then you might weight it a little higher with a value of 2, you know, or you might think, oh, percent no vehicle, yeah, you have trouble with public transportation, forget that. You know, we could make it a value of half as much. We're not going to mess with that. We're just going to keep them at 1. And then for this raster, this weighted walk, I'm going to click and go to our products and say food _ desert weighted sum, and it gave me a red X because I wants to have an extension, so .tif. Alright, food desert weighted sum TIFF. Okay, and let's look at our environments. Our environments should be set, you know, because we went up to this environments over here, remember? We did the environments under analysis, and we specified everything we want here. So it's really nice to set up your environments. It's actually a good habit to get into, because then whenever you go to run like another raster, do an analysis in this project, it'll always be the same. You don't have to constantly be resetting it. So all of our information is saved. All right, hit run. Okay, so this is the analysis of our food deserts. So the areas that have green are actually food deserts. So we want to change this symbology. I want to flip it, so I'm going to right click symbology, and I'm going to go click this invert. Okay, I'm going to click off our other layers. Okay, so it's, you know, you got to use some common sense when interpreting the results. These are food deserts, yes, but nobody really lives out there. So I probably would mask out these areas, you know, clip them out. I would focus on where people live. So looking in Anchorage, if I turn this off, we can see that it does pick up parks, you know, as food deserts. But like this area here is a food desert. These guys here, up in here, is a food desert. A Government Hill. Government Hill doesn't really have a grocery store up here, so this is definitely an area that was caught as a food desert up here. Looking around, you know, here is another area that looks a little low for food. It's around Merrill Field. Another food desert potentially right in here. Okay, in there. All right, so I want to look at this a little bit differently, so I'm going to go to symbology, and instead of stretch, I'm going to go to classify. And there's this thing called natural breaks, so it's just going to find the natural breaks in the data. And let's maybe try 3, just to see. Good grief. 3. And for my color ramp, some people are red and green colorblind, so I probably shouldn't do that. How about this one, the blue. So the natural breaks in the data, and this is, you can see, natural breaks, 1.75. It's just seeing where is there a natural divide in the data, and it's calling it there. So in this case, you know, 0 to 0.25 to 1.75, 1.75 to 3. So this is an example of potential, another way to look at the data. You might say that these purple areas within here are potential food deserts. If we go to 5, we can get even more hone in on where there might be areas of food deserts. So this is where, you know, you have your final result. We have our map of our food desert, and you know, we can use it to figure out where we might want to put grocery stores. So one thing that we could do is that you can use what's called the con tool to specifically call out different certain areas. So I'm just looking at this. Say that, you know, our values, when we look at the histogram, go from 0.25 up to 3.07. Say, for example, we were only interested in values that were 2 or above. So let's go back to our classes here, and let's actually put down 2. here. And for this upper value, what if we put like a 2? All right. So looking at that, if we were only interested in values that were greater than 2, that would be these pink areas. So, because the values that are 2 or less are the teal areas, the values that are greater than 2 are the 3s. So one last final step, to make this easier, say, for the public, if you're trying to display this to the public, is you could use what's called a con tool. So go up to your tools, and it's under Spatial Analysis Tools. So all the way down at the bottom of your toolbox, go down to Spatial Analysis, go to Conditional, double click Con. Now put your weighted sum raster there. And what we want is this value, and when this value is greater than 2, we want just to return a value of 1. And when that's not true, we want a value of 0. So this is going to give us a yes or no raster. 1 when we do have food deserts, 0 when we don't have food deserts. And so I'll go to our folder and I will do food desert con and 2 because that was our cutoff value .tif. Okay, so we just want to identify the areas where there's values greater than 2, and then hit run. All right, so turn off your other food desert. Go to your symbology, and so remember, all we really care about is where's the food desert, so make this no color, and there you go. So I would probably clean this up and clip out this giant area here, but now we can say where are the food deserts within Anchorage, and it's a little bit more visible as far as where they are. Let's see, map. Just want to see. We could go here. We can go to imagery. What is it? Raster layer. Okay, raster layer. We can make this transparent at like 50% up here, so that we can kind of see what's going on. So this area here with these houses, those are food desert area. This looks to be a food desert area. So if you wanted to figure out where maybe you need to put some more stores for people to get to, this would help you make that decision. And that is it for the food desert exercise. So I will have instructions as far as what to turn in, to show that you did this assignment. So there you go. Hopefully that was helpful.